This video is for blended geometry for the note card for Chapter 8 test. So go ahead and get a piece of paper out, put your name on it. I'm going to go through each section and the things that are going to be important for Tuesday's test. So the 8.1 was all about the Pythagorean Theorem. And what we said about the Pythagorean Theorem was that it was a squared plus b squared equals c squared. Okay, that's what the theorem is. Okay, and what a, b, and c are, if you have a right triangle, a and b have to be the legs, and c has to be the hypotenuse. Okay, so you always have the hypotenuse as c, and then the other two are legs. This is a leg, and this is a leg. Okay, so the hypotenuse is always c, and then the formula a squared plus b squared equals c squared will help you find that missing side. Sometimes you're missing a leg, sometimes you're missing the hypotenuse. Okay, if it says to classify a right triangle, okay, there are three options there. Okay, there's three options here. It could be, oops, I wanted one more thing in my table here. Three things could happen. You could end up with an acute triangle, with an obtuse triangle, or with a right triangle. So with that, we're always looking at how does c squared compare to a and b squares. So acute was always when c squared compared to a squared and b squared. That was when it was less than. If the hypotenuse squared is smaller than the two sides added up, it was an acute triangle. If the hypotenuse squared is bigger than the legs squared, so greater than, that made it obtuse. And if it was equal, that made it a right triangle. So those are the two things that you want to know in terms of Pythagorean Theorem. How to use it to find the missing side, and then how to classify using acute, obtuse, and right. Remember that we don't want decimal answers, okay, unless the directions say otherwise. Okay, so what that means is you need to simplify the square roots. Okay, so you have to make sure that you write it in terms of a simplified square root. All right, let's move on to 8.2. Two types of triangles to be concerned about. One of them is a 45-45-90. One of them is a 30-60-90. All right, and they both have some rules. Okay, so what we know is that with 45-45s, they're called right isosceles triangles. What that means for us is the legs have to be the same. So if this is x, then this has to be x. They have to be the same number. If I want to go and get the hypotenuse, I would have to multiply by square root of 2. Okay, so this would be like x times the square root of 2. If I knew the hypotenuse and I wanted to know the leg, it would be like divide by square root of 2. So with 45-45-90s, the rule is we either have to multiply or divide by square root of 2. So if you wanted to put some more right here, you could write the steps. So from leg to hypotenuse, times square root of 2. From hypotenuse to leg, divide by square root of 2. With 30-60-90s, you end up with a short leg, you end up with a long leg, you end up with a hypotenuse. Okay? All roads go through the short leg. So you either are given the short leg or you need to find the short leg first. That's the easiest thing to do. Okay? If you know the short leg, you have to double it, times 2. to get to the hypotenuse. If you know the short leg, you have to multiply it by square root of 3 to get the long leg. And then it can work backwards. So if you know the hypotenuse and you want to get to the short leg, you divide by 2. If you know the long leg and you want to get to the short leg, you divide by square root of 3. Remember that you can't leave a square root in the denominator. That was something called rationalizing. So if you wanted to add something about rationalizing to the note card, that would be perfectly fine. Let's move on to 8.3. Most important thing you can write is Sohcahtoa. Okay, you use regular Sohcahtoa to find sides. You use inverse Sohcahtoa to find angles. The Sohcahtoa, what this is a little memory device for when to use sine, cosine, or tangent. So S stands for sine, and sine is equal to the opposite side over the hypotenuse. Cosine is what C stands for. That's equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. So let's draw a picture. When you're looking at a right triangle, there's going to be some angle that we know. From there, you want to figure out where is the opposite side, where is the hypotenuse, and where is the adjacent side. From there, you can decide using Sohcahtoa if you should use sine, cosine, or tangent. Make sure that you know how to use your calculator, and if you don't know how, you need to ask your teacher as soon as possible before the test. You need to be able to type these in to get an answer. 8.4 was about angles of elevation and angles of depression. Angle of elevation means up. Angle of depression means down. So there's some where you have to solve and set up and maybe even draw your own pictures to help answer word problems. One thing that I'll point out to you again that's important to know is that if you have an airplane, okay, and you have a person on the ground, so the pilot in the airplane has to look down at a certain amount of degrees to see the person. That's the same amount of degrees the person has to look up to see the plane. So the angle of depression, the angle looking down is always equal to the angle of elevation looking up. So these are called alternate interior angles. So if you get an angle of depression in your word problem, you need to know that that means this angle has to equal this angle. So it's usually more helpful to use this one, and then you can start doing your O, H, and A. And the last section of chapter 8 is 8.5, which is all about vectors. So vectors are just something that has magnitude and direction. So that's what it means. So I might have problems where you have to find the magnitude, or you have to find the direction, or you have to find both. So here's a picture of a vector. Okay, maybe we even look at north, east, south, west as something to remember. Okay, my vector would be this here in red. The magnitude is C on the picture. Okay, it's how long that side is. And direction would be like X, the angle. So X degrees right here. So we've talked about how north of east or east of south or whatever it might be. All right, a couple of things. Another little table. Okay, vector table. Okay. Okay, if you are supposed to find if you're supposed to find the magnitude, what you need to do is think of it as a right triangle. If you need to know the magnitude, then you know this side and this side. What you do is a squared plus b squared equals c squared. If you need to find the direction, of a vector, it's always going to be inverse tangent, because you'll know this side, which is opposite. You'll know this side, which is adjacent. So if you take that and you take your opposite and adjacent, you're going to use tangent. The inverse tangent helps you find angles. The last thing I'll put in this table for vectors is I might ask you to find a resultant. Okay? That just means add. So you're adding vectors together if it says resultant. So they'll give you two vectors and you're adding them together to get a total, a result. One thing I forgot with vectors, make sure that you're using those compass directions. So if it's a problem that asks you magnitude and direction, you're going to use those to, you're going to use, part of the answer for direction will be the compass part, south of west, north of east, whatever it may be. Hope that helps. You can certainly put more than this on your note card, but this is a really good starting point. Thanks for watching.